Let's start with something so ordinary that you've probably never questioned it. Take a breath. Not a deep one, just a normal, casual breath. The kind you take every few seconds without noticing. It happens while you're watching a video, scrolling your phone, or sitting quietly. It feels so automatic that it almost doesn't feel like an action at all. It feels like background noise in your own life. Now here's the strange part. That simple act, air moving in and out of your nose, is quietly changing your brain chemistry, not metaphorically, not in some poetic sense, literally. Your nose is not just a hollow pipe that lets air pass through. It is an active system full of structure, sensors, and hidden processes that interact with your brain in real time. The moment air enters your nostrils, it doesn't simply travel straight to your lungs. It is slowed down, twisted through narrow passages, warmed to match your body temperature, and filtered by tiny hairs and mucus that trap particles you didn't even know were there. While all of this is happening, something even more interesting is going on. Your nose is constantly measuring the air you breathe. It detects how fast the air is moving, how warm or cold it is, how dry or humid it feels. These are not details you consciously notice, but your nervous system does. It receives a continuous stream of signals from your nose, like a quiet conversation happening beneath awareness. So before oxygen even reaches your lungs, your brain has already begun reacting. This challenges the simple story we were taught. The textbook version says breathing is about oxygen going in and carbon dioxide going out. That's true. But it's like saying a computer is just electricity flowing through wires. It misses the deeper structure, the information, the control, the feedback loops. Breathing is not just a supply chain for oxygen. It is part of a regulatory system. It helps set the tone of your internal state. Think of it like this. Imagine walking into a room where the lighting, temperature, and background noise are constantly adjusting based on how you move. You don't consciously control those changes, but they still affect how you feel, whether you're relaxed, alert, or uncomfortable. Your nose is doing something similar, but instead of adjusting a room, it is influencing your brain. Every breath carries not just air, but information. The pattern of your breathing, fast or slow, smooth or irregular, feeds into your nervous system and subtly shifts its behavior. You don't notice this happening moment to moment, just like you don't feel individual seconds passing. But over time, these tiny changes accumulate. That's what makes this so easy to overlook. There is no dramatic moment where your mind suddenly changes because of a single breath. Instead, it's a continuous process happening quietly, shaping your internal state in the background. And because it's always there, you stop seeing it. It becomes invisible, not because it's unimportant, but because it never turns off. So the next time you take a breath, consider that it isn't just air moving through your body. It's the beginning of a chain of events, physical, chemical, and neurological, that starts in your nose and reaches all the way into your brain, subtly influencing what you feel, how you think, and who you are in that moment. Inside your nose, there is something happening that almost no one thinks about, even though it is occurring with every single breath you take. Your body is quietly producing a gas, not in your lungs, not in your stomach, but right there in the narrow, winding passages behind your nostrils. This gas is called nitric oxide. You don't feel it. You don't smell it. There is no obvious sensation that tells you it exists. And yet, it is constantly being generated in small amounts by the lining of your nasal passages. It mixes with the air you inhale and travels deeper into your body without any conscious awareness. At first, this sounds like a small detail, just another chemical among many. But nitric oxide does something surprisingly powerful. When it reaches your lungs, it acts like a signal, not a nutrient, not a fuel, but an instruction. It tells the tiny blood vessels in your lungs to relax and widen. This process is called vasodilation, but you don't need the word to understand the idea. Imagine a network of very small tubes carrying blood. If those tubes are slightly squeezed, less blood can flow through them. If they relax and open up, more blood can pass. Nitric oxide tells those tubes to open, and when they open, something important happens. The exchange between air and blood becomes more efficient. Oxygen moves more easily from the air you just inhaled into your bloodstream. Carbon dioxide moves out more effectively. The whole system becomes smoother, more optimized, like a road where traffic suddenly starts flowing without congestion. So the air you breathe through your nose is not just delivering oxygen. It is carrying a built-in enhancer that improves how that oxygen is used. Now consider what happens when you breathe through your mouth instead. Air still enters your lungs. Oxygen is still present, but the journey is different. The air bypasses the nasal passages, which means it doesn't pick up the same amount of nitric oxide. The signaling effect is reduced. The tiny blood vessels in the lungs don't receive the same instruction to open as effectively. So even though the air is the same, the outcome is slightly different. It's like two identical deliveries arriving at a factory, but one comes with a note that says, "Prepare everything, open all systems," and the other arrives silently. The contents are the same, but the response inside the factory changes. These differences are not dramatic in a single moment. You won't feel a sudden shift and think, my nitric oxide levels just changed. The body doesn't work that way. It operates through subtle adjustments, small changes that add up over time. And that's what makes this so easy to ignore. We tend to notice things that are immediate and obvious: pain, pleasure, sudden changes. But nitric oxide is part of a quiet system. It works continuously without calling attention to itself. It doesn't demand awareness. Yet it is influencing how efficiently your body uses every breath you take. There's also something deeper here. Nitric oxide is not just involved in breathing. It appears in many parts of the body, acting as a signaling molecule in the brain, the immune system, and the cardiovascular system. It is one of those simple substances that plays multiple roles, depending on where it is and how it is used. This hints at a broader pattern in biology. The body doesn't rely on single-purpose components. Instead, it reuses the same basic tools in different ways, creating complex behavior from simple parts. So when you breathe through your nose, you are not just pulling air into your lungs. You are engaging a system that produces and delivers a chemical signal, one that quietly adjusts how your body functions at a microscopic level. And all of this is happening without you ever noticing it, as if your body is running a hidden experiment with every breath, fine-tuning itself in ways that remain just below the surface of awareness. Now consider something even stranger. Breathing does not just affect your lungs or your blood. It reaches into your brain and quietly changes how it behaves. It's tempting to think of the brain as the control center and breathing as something it simply manages in the background, like a machine keeping itself running. But the relationship is not that simple. It goes both ways. The brain controls breathing, yes, but breathing also feeds back into the brain and shapes its activity. Imagine your brain not as a solid, unchanging object, but as a constantly shifting pattern of electrical signals. Billions of neurons are firing in rhythms like a vast network of tiny oscillations. Some of these rhythms are associated with attention, some with relaxation, some with memory, and some with emotion. Now introduce breathing into this picture. Every time you inhale and exhale, you create a rhythm. It is slow compared to neural activity, but it is steady and continuous. And this rhythm does something important. It interacts with the rhythms of the brain. Signals from your breathing, coming from sensors in your nose, your lungs, and your chest, travel to areas deep inside the brain. These areas are involved in regulating things like alertness, emotional tone, and basic survival responses. The timing of your breath begins to influence the timing of neural activity. This is not like flipping a switch. It is more like nudging a system that is already in motion. If your breathing becomes fast and shallow, the signals reaching your brain change. The pattern becomes tighter, more rapid. This tends to push the brain toward a state of alertness. Muscles may tense slightly. Attention narrows. The system prepares in a subtle way for action. If your breathing becomes slower and more regular, the pattern shifts in the opposite direction. The signals are more spaced out, more stable. The brain responds by moving toward a calmer state. Muscles relax. Attention broadens. The system becomes less reactive. You don't have to consciously decide any of this. It happens automatically. This creates a loop. Your brain influences how you breathe, and how you breathe feeds back into your brain. It's a circular system, not a one-way command. And this loop can amplify itself. If something startles you, your breathing may become quick and shallow. That change in breathing sends signals back to the brain, reinforcing the sense of alertness. The brain then maintains or even increases that breathing pattern. The loop continues. On the other hand, if your breathing slows down for any reason, the signals encourage the brain to settle. The brain then supports that slower pattern, and the system stabilizes in a calmer state. This is not about control in the usual sense, it's about influence. Breathing does not dictate what your brain must do, but it biases the probabilities. It makes certain states more likely and others less likely. Think of it like adjusting the slope of a surface. A ball placed on a flat surface can roll in any direction, but if you tilt the surface slightly, even by a small amount, the ball will tend to roll one way rather than another. Breathing is like that tilt. And because this process is continuous, happening every few seconds, the effect accumulates. Over time, the patterns of breathing you tend to fall into can subtly shape the baseline state of your nervous system. Not in a dramatic or easily measurable way, but in a persistent background sense. This is why it is difficult to notice. There is no single moment where the change becomes obvious. There is no clear boundary where you can say, now my brain has shifted because of my breath. Instead, the influence is always there, quietly adjusting the system. So the next time you think of breathing as something simple and automatic, it's worth remembering that each breath is part of a conversation between your body and your brain, a conversation that never stops, and one that continuously shapes how you experience the world from the inside. Imagine two people who are, in every obvious way, identical. They have the same body, the same brain structure, the same memories, the same environment, and they go through the same daily experiences. If you looked at them from the outside, you wouldn't be able to tell them apart. Even if you could look inside their brains, neuron by neuron, everything would appear the same at the start. Now introduce a single, almost trivial difference. One of them tends to breathe slowly, gently, and mostly through the nose. The other tends to breathe more quickly, a bit more irregularly, often through the mouth. That's it. No other differences. At first, nothing noticeable happens. Both people wake up, go about their day, think, react, and behave in ways that seem nearly identical. If you observe them for a few minutes, you would conclude that this small difference in breathing doesn't matter. But the body is not a system that responds only to large changes. It is a system that integrates countless small signals over time. With each breath, the first person is sending a slightly different pattern of signals into their nervous system compared to the second. The airflow through the nose is more structured, more filtered, carrying subtle chemical signals like nitric oxide. The rhythm is slower, more regular, creating a steady pattern of input to the brain. The second person, breathing more through the mouth, experiences a different pattern. The airflow is less regulated, the chemical contribution from the nasal passages is reduced, and the rhythm may be more variable. The signals reaching the brain are not dramatically different, but they are not the same either. These differences are tiny. On any given breath, they are almost meaningless. But now let time pass. Minutes become hours, hours become days, days become years. The nervous system is constantly adapting, constantly recalibrating itself based on incoming signals. It is always asking, in a sense, what kind of environment am I in? What state should I maintain? The first-person system receives a steady, calm pattern of input. Over time, it may lean slightly towards stability, efficiency, and a kind of quiet balance. The second-person system receives a more irregular pattern. It may lean just slightly toward reactivity or tension, not enough to create a dramatic difference, not enough to define their personality in a clear, obvious way, but enough to create a subtle drift. It's like two clocks that start perfectly synchronized but run at slightly different speeds. At first, the difference is too small to notice, but as time passes, the gap grows. Or imagine two paths that begin at the same point but diverge by a tiny angle. After a short distance, they are still very close. After a long distance, they lead to entirely different places. This is how small physiological differences can shape experience. The important thing is not the size of the effect at any single moment. It's the persistence of the effect over time. And this is where our intuition often fails us. We are good at noticing big causes and big effects. If something changes dramatically, we can connect the dots. But when a cause is small and continuous, and the effect is gradual and distributed, it becomes almost impossible to track. You cannot point to a specific day and say, "This is where the difference in breathing changed everything." There is no clear turning point. There is only accumulation. So when we think about ourselves, our moods, our habits, our tendencies, we often look for explanations in big events or obvious factors. We rarely consider that something as simple as the way air moves through our body thousands of times a day might be quietly contributing. This doesn't mean breathing determines who you are. That would be an oversimplification. But it does mean that even the smallest, most automatic processes can participate in shaping the system, and that realization changes the scale at which you have to think. Instead of looking only at the large, visible pieces, you begin to see that the background processes, the ones that never stop, may be just as important. Precisely because they never stop. If all of this is happening, if breathing is quietly influencing your brain, your chemistry, and your internal state, then a natural question appears. Why doesn't it feel important? Why does it still seem like just air? The answer has less to do with breathing itself and more to do with how human perception works. Your brain is not designed to show you reality as it is. It is designed to filter reality so that you can function. Out of the enormous amount of information flowing through your body every second, only a tiny fraction reaches your awareness. The rest is handled automatically in the background without ever becoming part of your conscious experience. Breathing falls into that hidden category. It is constant, it is repetitive, it rarely changes in a dramatic way, and because of that, your brain classifies it as unimportant for conscious attention. It becomes part of the baseline, like the hum of a fan in a room or the feeling of clothes on your skin. These things are always present, but you stop noticing them precisely because they don't demand attention. There's also another limitation. Humans are much better at understanding cause and effect when the connection is immediate and visible. If you touch something hot and feel pain, the link is obvious. If you push an object and it moves, the relationship is clear. But breathing doesn't work like that. You don't take a single breath and suddenly feel a clear, measurable shift in your thoughts. The effects are subtle, distributed, and delayed. They operate through complex systems, chemical signaling, neural rhythms, feedback loops that don't produce a simple one-to-one outcome. This creates a kind of perceptual blindness. The cause is too small to notice in isolation, and the effect is too gradual to trace back to a single moment. So the connection disappears from your awareness, even though the process is continuously active. There's also the problem of scale. Most of the important processes in your body happen at levels you cannot directly observe. Molecules interacting, cells signaling, tiny changes in electrical activity across networks of neurons. These are not things you can see or feel directly. They are too small, too fast, or too complex. So your mind builds a simplified model of the world. In that model, breathing becomes a simple mechanical act, air in, air out. It ignores the layers of chemistry and signaling because including them would make the model too complicated to use in everyday life. This simplification is useful, but it comes at a cost. It hides the deeper structure of what is actually happening. There is also a tendency to separate things that are actually connected. You think of your mind as one thing and your body as another. Thoughts feel abstract, while breathing feels physical. So it seems natural to assume that one has little to do with the other. But that separation is artificial. Your thoughts emerge from physical processes in your brain, and those processes are influenced by signals coming from your body. Breathing is one of the most constant sources of those signals. The difficulty is that this connection does not present itself clearly. It doesn't announce, "This feeling came from that breath." It doesn't label its own causes. It simply operates. And so you are left with an experience that feels self-contained, even though it is being shaped by systems you are barely aware of. This is a general feature of complex systems. When many small interactions combine, the overall behavior becomes hard to trace back to individual components. The system appears unified, even though it is built from countless parts. Your experience of being you is like that. It feels like a single, continuous thing. But underneath, it is the result of many overlapping processes. Breathing, chemistry, neural activity, all interacting in ways that are mostly hidden. So breathing remains invisible, not because it is insignificant, but because it is too deeply integrated into everything else to stand out on its own. And that may be the most interesting part. The processes that matter the most are often the ones you never notice, precisely because they are always there, quietly shaping everything without interruption. Now return to the idea that your nose behaves like a kind of drug factory. At first, that sounds exaggerated, almost misleading, because we usually associate drugs with something external, something you take into your body that changes how you feel or think. But if you look more carefully at how your body works, the distinction between internal and external starts to blur. Your body is constantly producing chemicals that act on your brain. These chemicals can increase alertness, reduce pain, shift your mood, or change how you respond to the world. In that sense, the body is already a highly sophisticated chemical laboratory, continuously generating its own regulators. Breathing is one of the ways this internal chemistry is adjusted. When you inhale through your nose, you are not only bringing in oxygen, you are also influencing levels of gases like carbon dioxide and nitric oxide, and these gases are not just waste or byproducts. They act as signals. They change how blood flows, how neurons behave, and how different systems in the body coordinate with each other. Carbon dioxide, for example, is often thought of as something the body needs to get rid of. But it plays a crucial role in regulating the acidity of your blood and the release of oxygen from hemoglobin. If carbon dioxide levels drop too low because of rapid or shallow breathing, the balance shifts. Oxygen may be present, but it is not delivered to tissues as effectively. So even something that seems like a waste product becomes part of a control system. Nitric oxide, produced in the nasal passages, adds another layer. It helps regulate blood flow and improves the efficiency of oxygen exchange in the lungs. It also appears to have effects beyond the lungs, influencing communication between cells in different parts of the body. These are not isolated chemicals acting alone. They are part of a network, and breathing acts like a dial that adjusts this network in real time. If your breathing becomes faster, you tend to exhale more carbon dioxide. That changes the chemical balance in your blood. If your breathing slows, carbon dioxide levels shift in the opposite direction. Each pattern creates a slightly different internal environment, and your brain is sensitive to these changes. This is why it makes sense in a scientific way to describe breathing as drug-like, not because it introduces foreign substances, but because it modulates the concentration and effect of substances that influence your state. The difference is that this drug factory is built into your body, and it operates continuously. There is no off switch. You are always adjusting your internal chemistry, even when you are not aware of it. This leads to an interesting perspective. Instead of thinking of your state of mind as something fixed that occasionally changes, you can think of it as something constantly being tuned. Like a radio signal that is always being adjusted, even if only slightly. Breathing is one of the main controls for that tuning. But unlike most controls, it sits at an unusual boundary. It is both automatic and voluntary. You can ignore it completely and it will continue on its own. Or you can pay attention to it and change it deliberately. Very few systems in the body work this way. Your heartbeat, for example, is mostly beyond direct control. Your digestion operates without your input. But breathing exists in between. It is managed by automatic processes, yet it can be influenced consciously. This makes it a kind of interface between different levels of the system. On one side, there are unconscious processes regulating chemistry and physiology. On the other side, there is conscious awareness, the part of you that can decide to act. Breathing connects these two. And yet, even with this connection, most of what breathing does remains hidden. You can change the rhythm of your breath, but you cannot directly feel the changes in nitric oxide or carbon dioxide. You cannot sense the exact shifts in blood flow or neural activity as they happen. So you are interacting with a system you cannot fully perceive. This is another reason it feels simple when it is not. The control is accessible, but the consequences are largely invisible. And so the idea of your nose as a drug factory is not a metaphor in the usual sense. It is a way of pointing to a real physical process, one where your body continuously produces and distributes chemical signals that influence your brain and your experience, all through something as ordinary as the act of breathing. It is tempting at this point to think that if breathing influences so many systems, then we should be able to map it cleanly, measure a few variables, draw a diagram, and fully understand how a breath turns into a change in thought or emotion. But this is where things become less clear. The human body is not a simple machine with linear cause and effect. It is a complex system with layers of feedback, where one change influences many others, and those changes loop back in ways that are difficult to separate. Take something as basic as a single inhale. Air enters your nose, picks up nitric oxide, moves into your lungs, and affects oxygen exchange. At the same time, the mechanical expansion of your chest activates stretch receptors. These receptors send signals through nerves to the brainstem. Meanwhile, the rhythm of the breath interacts with ongoing neural oscillations in various regions of the brain. Carbon dioxide levels begin to shift slightly, altering blood chemistry. Blood vessels respond. Heart rate may subtly adjust. All of this happens within seconds. And none of these processes operate independently. They influence each other. A small change in carbon dioxide can affect blood pH, which can influence how neurons fire. Changes in neural activity can alter breathing patterns in return. Signals from the lungs can modify heart rhythms, and heart rhythms can feed back into brain activity. It is a network of interactions, not a chain. This makes it extremely difficult to isolate one variable and say, this is the exact cause of that specific mental state. Even when scientists study these systems in controlled conditions, they often find correlations rather than clear, simple explanations. A certain breathing pattern might be associated with a certain brain state, but the underlying mechanism may involve multiple overlapping pathways. And this leads to an important limitation in our understanding. We can describe parts of the system. We can measure gases in the blood. We can observe brain activity. We can track heart rate and airflow. But connecting all of these into a complete, unified model remains a challenge. Part of the difficulty comes from scale. The processes involved operate across very different levels. Molecules interacting at a microscopic scale influence cells. Cells form tissues. Tissues form organs. Organs interact through networks like the nervous system and the circulatory system. And all of this contributes to something we experience as a single, unified state of mind. Trying to trace a path from a single breath to a specific thought is like trying to track one drop of water in a river and explain how it shapes the entire current. You can follow part of the journey, but the system is too interconnected to isolate completely. There is also the issue of variability. No two breaths are exactly the same. No two moments in your brain are identical. The system is constantly changing, adapting to internal and external conditions. This means that even if you repeat the same breathing pattern, the effect may not be identical each time. This unpredictability is not a flaw. It is a feature of complex systems. It allows flexibility, adaptation, and resilience. But it also makes precise explanations difficult. So when we say that breathing influences the brain, we are describing a real phenomenon. But we are also simplifying it. We are compressing a vast network of interactions into a statement that is easier to understand. This is necessary because the full detail would be overwhelming. And yet, it is important to remember that the simplicity of the explanation does not reflect the simplicity of the system. There is still a great deal we do not know. We do not fully understand how breathing rhythms synchronize with different patterns of brain activity. We do not have a complete picture of how chemical signals, mechanical signals, and neural signals combine to produce specific experiences. We cannot yet predict with precision how a change in breathing will influence a particular individual in a particular moment. So we are left in an interesting position. We know enough to see that breathing matters in ways that go far beyond basic oxygen exchange. But we do not know enough to fully explain how all the pieces fit together. And that gap between what we know and what we can fully understand is not a failure. It is a reminder of how complex even the most ordinary processes can be. Something as simple as a breath turns out to be part of a system that is still, in many ways, a mystery. Step back from all the details, the gases, the signals, the neurons, and look at the larger picture that is starting to form. You probably think of yourself as something stable, a continuous person moving through time, having thoughts, making decisions, reacting to the world. It feels like there is a clear boundary between you and everything outside you. Your body is you, and the air around you is not you. But breathing quietly challenges that idea. Every few seconds, something from outside your body enters it, not just as a passive substance, but as something that immediately becomes part of your internal processes. The air you inhale does not stay separate. It mixes, reacts, dissolves into your blood, and within moments it is influencing the activity of your cells. In a very real, physical sense, the outside world is constantly becoming part of you. And just as quickly, parts of you are returning to the outside world with every exhale. This exchange never stops. There is no moment where you are completely isolated from your environment. Even if you are sitting still, doing nothing, this continuous flow is happening. It is one of the most basic conditions of being alive. Now consider what that means for your experience. Your thoughts and feelings feel internal, as if they originate entirely within you. But the processes that generate them depend on inputs that come from outside. Oxygen levels, carbon dioxide balance, chemical signals carried by the air you breathe, all of these contribute to how your brain functions from moment to moment. So the boundary between outside and outside becomes less clear. It is not a solid wall. It is more like a moving interface where exchange is constantly taking place. Breathing is one of the simplest examples of this, but it points to a deeper principle. You are not a closed system. You are an open system, continuously interacting with your environment in ways that shape what you are. This idea is easy to state, but difficult to fully grasp because it conflicts with how things feel. Your experience is centered inside your mind. You do not feel the air becoming part of your blood. You do not sense the chemical changes as they happen. All of that occurs below the level of awareness. So your brain constructs a simpler story. It presents you with a sense of being a separate, self-contained entity. This is useful for navigating the world, but it hides the underlying reality of constant exchange. Breathing exposes that hidden layer. It shows that something as fundamental as your state of mind is not purely internal. It is influenced by a continuous interaction with the environment, happening through processes you do not directly perceive. This leads to a shift in perspective. Instead of thinking of yourself as something fixed that occasionally interacts with the world, you can begin to see yourself as something that is continuously being shaped by that interaction. Not in a dramatic or philosophical sense, but in a literal, physical one. Each breath is part of that shaping process. Each inhale brings in new material and new signals. Each exhale removes something and resets part of the system. The cycle repeats over and over, maintaining a dynamic balance that allows your brain and body to function. And because this cycle is so constant, it becomes invisible. You don't notice it for the same reason you don't notice the passage of time second by second. It is too continuous to stand out. But if you pause and look closely, you begin to see that what feels stable is actually the result of ongoing change. You are not a static object that breathes. You are a process that includes breathing as one of its essential components. And once you start to see yourself that way, not as a fixed thing, but as a continuous interaction, the ordinary act of taking a breath begins to look very different. It is no longer just a background function. It is part of the mechanism that makes you what you are, moment by moment,